Good evening again, and welcome back to AP Stats Notes Online. In the last set of notes, we talked about the chi-squared test for homogeneity, which utilized a two-way table and how to go through and determine if two different groups had the same distribution for a particular categorical variable. Now we're going to talk about the last type of chi-squared testing, where we're going to take one group, we're going to sample one group, and look and see if there are two categorical variables that have a relationship, that have an association, or if they are in fact independent of one another. Now, the good news is the test itself is exactly the same. And so I'll go through this very quickly, and we'll be done. Okay? So, a chi-squared test of independence. One population is cross-categorized on two variables to see if there's an association between them. Are the variables independent? Okay. For example, is there an association between eye color and handedness? Data was collected from a random sample of MHS is Magruder High School, and we'll stick with Magruder High School for right now instead of trying to change it over to FCHS. Okay. But anyway, data was collected from a random sample of Magruder High School students, and they measured on 26. Sorry, that's not how many. On the total here. So it would be helpful if we had some marginal totals here. 37 and then 33, I believe. 37, 33, yes. This is 60, this is 70, this is 151. So 151 were randomly selected. And this is the breakdown of eye color and handedness. Okay? So, what do we want to know? Well, is there an association between eye color and handedness? If you're left-handed, are you going to be blue-eyed, right? Or, it looks like the two-way table right now suggests that you're more likely to be brown-eyed. And so, let's go take a look, right? To see if there's an association, we're going to do a significance test. And again, our null hypothesis being the statement of no difference, right? Then it needs to say that there is no association between eye color and handedness, okay? They are independent. We are going to assume that eye color and handedness are independent. So what are we looking for evidence of? We're looking for evidence of an association, for them to not be independent. So our alternative is there is an association between handedness and eye color. All right. Let's go see what we can see. Okay? So plan it out. We're going to do what's called a chi-squared test of independence. Okay? Or chi-squared test of association, or for association. Okay? And we're going to do it at a 0.05 level. Because ultimately it doesn't matter if we commit a type 1 or a type 2 error. Alright. Here are some things to keep in mind. Okay? The data must be counts for the categories of a categorical variable, of course. Okay? But our conditions that need to be met. The sample isn't random, so my guess is this is a teacher's 151 students, but we're assuming that it's representative of all MHS students. Now we can pretend, right, again, we're just trying to get the nuts and bolts of a test, that this is a random sample. We could definitely randomly sample 151 students and do the same thing, okay? But we're going to move on, even though this isn't a random sample. Expected cell counts, we're going to go ahead and say that they're all bigger than or equal to 5. Once we run the test, we're going to check that and make sure that that is indeed true, okay? And then, what's not listed here, but we need to list here, is our last condition, which is we're going to have to assume that there are more than 1,510 students at Magruder High School. Okay, it's a large high school, so we can. It's probably a safe assumption to make. We do need the 10% condition here because we are supposed to be randomly sampling from the population. Okay, so those conditions are met. We're ready to go do the test. It's just like from yesterday. To get our expected counts, we're going to do row total times column total and divide it by the table total. What would not be a bad idea here, and I'll let you know if this is necessary in this class or on the AP exam, is to go ahead and write out the expected counts, maybe even in the form of a table. I'll do some research and some thinking on that and decide if that actually needs to happen. Okay, but we want to show the expected counts probably so we can verify that they are actually bigger than 5. Okay. So, we're going to go do our test. Degrees of freedom, 1 less the number of rows, 1 less the number of columns. Multiply those two together. Here, in this particular example, we've got 2 rows, 2 columns, 3 rows, 2 columns. And so we're going to do 2 times 1, which our degrees of freedom just becomes 2. Okay? And then our chi-squared test is done the exact same way. When we get into our calculator, we create a matrix A, and then when we get into our chi-squared test, we ask it to dump our expected counts into matrix B. Okay, I won't go through that again. We did 2 in the previous set of notes. I think that's probably enough. Okay, if there's any question on that, there's a technology corner or 2 in section 11.2 in your book that will help you get through that. Okay, if we were to run that, we would see that the chi-square statistic here is 2.2444, which gets us to a p-value of 0.3256. Again, our degrees of freedom is 2, so a p-value of 0.3256 is definitely bigger than 0.05. We are going to fail to reject the null. Okay? And so we do not have enough evidence to suggest that there's an association between eye color and handedness, as we might have expected. Okay? But anyway, quick run through on a test for an association or independence. Now, like I said, it is exactly the same as the test for homogeneity. Okay? So how do we tell the difference? Which test we're performing? Is it a goodness of fit test? Is it a test for homogeneity? Which one are we actually performing here? Okay? And how are they different? It's all about the way the data are gathered. Now, first and foremost, a goodness of fit test we're going to perform if we just want to know if one categorical variable from one group has a distribution that there's a claim that it is claimed to have. If I could talk tonight, okay. It's one group, one variable. That's your goodness of fit. Homogeneity and association both use two-way tables, but it's how the data is gathered and how it's generated. If there's only one sample and we're measuring 2 variables, then we're testing for an association. If there are 2 different groups and one variable, like national group and FCHS group, and the variable is the score on the AP exam, then we're testing for homogeneity. Okay? The only difference is how you word your hypotheses. And obviously, when you list or you state the type of test that you're using. Okay? So do be careful there. Do pay a lot of attention to where your information and where your data is coming from. And that will drive you towards the test that you want to perform. Okay? That's it for these notes. Pretty short and sweet. Not a whole lot to talk about here, so we'll stop here. Homework is there for you to work on, and we will see you guys in the next class period.